All right, now, at long last, we are going to get into converting from one type of graph to another. So, first off here, on the left, I know this is a displacement graph because I have both positives and negatives involved, implying that direction is playing a role. I'm going to assume that we are using the standard physics units here. Oh, Captain Adam, how are you doing, fine sir? So, distance or displacement is usually measured in meters. If you're going to do math, you need to get your distance or your displacement to meters. No ifs, ands, or buts. Time is usually measured in seconds. Again, most formulas are geared to these particular units. And I'm just going to make my life easy and assume that that's what we are talking about. If I look at this graph, I see that there are 4 distinct things happening. 1, 2, 3, 4. Anytime you cross that 0 line, that 0 on your x-axis, pause and think. I always recommend to my students that you circle anytime that it crosses the x-axis, simply to draw your attention to that point. All right, so let's talk about what's happening here. We see an increasing displacement over a particular time. It is a straight line. I am increasing by the same amount with each passing moment. That implies, oops, sorry, wiggle, wiggle, stop. I have my camera balanced on this pile of books. I'm old school like that, sorry. Anyway, we are covering the same amount of ground with each passing second. So, to find our velocity, if you remember, velocity was distance over time. Formula for slope is y over x. Hey look, what's on y? What's on x? Same thing. Makes life easy. So, for line A, I am increasing from 0 to 5 on my y-axis. So 5 minus 0 is in fact 5. Divided by my change in time, we go from 0 to 5 once again. That is in fact 5. So the slope for my line A is in fact 1 meter per second. So that is the slope of the line. That is also the velocity of that particular line. My line that I draw over here on my velocity graph will be a straight line. There is no increase in my velocity over time. There is no curve to my line over here. It is a constant slope. So I go 1 meter per second for 5 seconds. And there it is. Constant velocity, constant nice straight line. If I look at B here, okay, I am moving backwards, okay, I am moving back towards my starting point, okay. Since I am moving back towards my starting point, I am moving in the negative direction. Oop, I didn't draw my picture. Why didn't you fuss at me? There we go. Since I am moving in the negative direction, this will be a negative slope. And again, that should make sense. Look at this line. To do y over x, let's see. We start at 5. We go to 0. Oops, sorry. I did that backwards, goofball. It takes me 5 seconds to do that? 5, 6, 7, 8, 9. Ooh, 4 seconds to do that. So 5 over 4, I have a negative slope, which is rather exciting because that's what I predicted would happen. So 5 over 4, that's what, negative 1.25? So 2, 4, 6, that's going to be right about there. So I'll draw a little dotted line to help us find it. 5, 6, 7, 8, 9. I'm doing this without a ruler, shame on me. So we're going to start at 5 and we're going to go all the way to 9. Once again, a constant velocity. There is no increasing in the amount of distance I'm covering per each second. Now, Line C. So this was line A, this is line B. Line C. I am moving away from my starting point, but again in the negative direction. So I am expecting a negative slope. Here we go. Let's see. We go to negative 5. We start off at 0. We go to 10, 11, 12. We start at 10. So that's a negative 5 over 2. A negative slope, just as I predicted. That's rather comforting. So 5 over 2, that's what? Negative 2.5, right? Is my brain doing that work? Yes. So my graph is not long enough. I apologize most profusely. 2, 4, 6, 8, 10. So from, oh no, you know what? I made a mistake. This goes from 9 to 12. This should be a 3. So, negative 5 over 3, that is 1.67. I apologize. It apparently is a slow day for me. One of those days. Happens to us all. So let's see. If I put 1.67, this is 2, 4, 6, so 0.67 would be just a hair below that. And here's 12. So, there it is. There is line C. And then line D, look at that. We stop moving. Stop moving means 0 velocity. There it is right there. So we have created a stepwise function. Oops, that line should not be there. I swear, I am not this dumb. I promise. Kids, your teachers make mistakes. We are human too. Sorry. Hate to disappoint you. But anyway, so again, my person is speeding or is walking away from my object. It is the same clip all the way across. A sloped line here leads to a straight line on our velocity graph. Direction matters. He turns around, goes back towards his starting point. Since we are moving in the negative direction, our velocity is in fact negative. At this point, it is important to note that he has reached his starting point again, so my displacement has started over. I am going from 0 at this point. So from here to here, we are walking away from my starting point in the negative direction. And it is at a steeper clip. We're moving faster than we were up here, so that reflected again in my graph. At line D, we stand still for a couple of seconds, replicated again on my graph. All right, let's look at some word problems. Let's see what we can draw here. So, problem says, a car started from home. So, I started at 0. Started right there on either of these graphs. It says it accelerated forward before reaching the highway and going at a constant velocity. So, accelerated forward. That is a positive acceleration no matter how you spin it. So, for some length of time, doesn't really tell me how much, but that's okay. My car goes at a constant acceleration, so my velocity is steadily increasing for a particular amount of time before reaching the highway and going at a constant velocity. Constant velocity means 0 acceleration. So, for the next length of time, we go at a constant velocity. So, no change in my velocity means acceleration is 0. Upon realizing that the occupant has left her physics book at home, oh no, the car slowed down before coming to a halt. So my velocity will decrease until I return to 0. Slowing down in the positive direction is in fact a negative acceleration. For a few moments, so she stopped there for just a minute. So we pause. And then accelerating, going faster in the opposite direction. So opposite direction means negative. We're going faster, but that doesn't matter. It's still in the negative direction. So my negative acceleration, and I'm going faster in that negative direction. So there it is, our graph. Let me quick number all those sections for you. Oh, I got plenty of time. So, first things first, we started at 0, as told to me by the word problem. Accelerated forward. So we'll call this part A. Keep numbers out of there for you. We accelerated forward upon reaching the highway and going at a constant velocity. Constant velocity means no acceleration, no change. Means a flat line over here on my velocity graph. Upon realizing that the book wasn't in the car, slowed down before coming to a halt. So slowing down. My velocity numbers are decreasing. Slowing down is in fact a negative acceleration. Coming to a halt for a few moments. So we stopped. Stop is 0, is 0, is 0. And accelerating in the opposite direction. So, numbers are getting bigger in the negative direction. Since it's in the negative direction, even though it's going faster, it is still a negative acceleration. So, piecewise function over here. Lines connected over there. So I hope this helps you see how graphs can be useful. They can be a wonderful pictorial representation of data, but they are not the end-all be-all. So they may help you understand, summarize what an object is doing, but oftentimes you need more information. So take your time with these graphs, if you're one of my kiddos or not. Always look at each line individually. If that line crosses the x-axis, pause, think. What could that mean? Did they stop? Did they turn around? Did they go back? Have they passed their starting point? Anytime that line crosses the x-axis, something happened. So pause, think. Best of luck in interpreting graphs. Again, they are not easy, but they show up on scary things like ACT, so it is best that you practice them. If you have any questions, be sure to leave them in the comment box below. Otherwise, I will see you next time.